Hey everyone, this is Lubin from eBay. Today, I would like to introduce ICWE2020-Liu-NuMessage, a generic messaging platform which providing scalable and reliable messaging service in a distributed system. Here is the outline. I will introduce some basic concepts we used in this paper, followed with the related works. Before showing the use cases in eBay, I will give detailed introduction of the design part. In the end, I will share the experiment results. Generally, three key concepts are defined in a messaging system: producers to generate messages, consumer to receive and processing messages, and messaging-oriented middleware to hold the messages. The message middleware is also called a broker or messaging server. There are two models of the messages applicable to different scenarios. One is the point-to-point scenario, and the other one is pub and sub scenario. In a point-to-point scenario, messages are sent to a specific queue until they are consumed or time out. The messages in a queue can only be consumed by one consumer at the same time. The order of messages in a queue is guaranteed. In a pub and sub scenario, topic is used to hold messages. The consumer with the same name but different ID are called in a consumer group. The messages in one topic will be shared by the consumers in the same group, while different groups will receive the whole volume of messages in this topic. According to how consumer receive the messages, the consumer could either be a push model or a pull model. Let's see some related works. In this paper, we divided the related work into two categories. One is messaging. The first category is traditional messaging systems. For example, RabbitMQ. RabbitMQ is an open source messaging middleware based on AMQP protocol, which is widely used in financial and payments systems. In the traditional messaging system, messages are usually persisted in memory or relational database on the broker side. The consumers can acknowledge the processing status on message level, and the status of message on broker side will be updated accordingly. These products usually have straightforward interface and configuration, so easier to use. Due to managing too many states for each message, the performance, the throughput of them are relatively low from a big data perspective. The second category is streaming system, also called as log system. Kafka is one of the widely used log system today. In the log system, messages are usually persisted in append-only log files. Most of the cases, the consumer will fetch back the data in a sequential way. The messages saved in a log system are usually have connections with each other and will be processed together. For example, eBay saved the user behavior data in Kafka, and a typical use case to process this kind of data is grouped by user ID in a time window. One single message in a log system is not critical, and a log system usually using the position read in a log to manage the acknowledgement state for a whole consumer group. To understand the design concept and a design and concept in a log system need some distributed system background, and the class need to be well designed to cover all the scenarios. One of the key advantage of log system is the throughput is extremely high, even from a big data perspective. NuMessage is a generic messaging platform, and from the interface and the capability perspective, NuMessage is more like a messaging system, and from the performance perspective, it could be near to a log system. To highlight the key benefits of NuMessage, we summarized into 4 perspectives. Firstly, NuMessage is user-friendly. It provides simple API, and the consumer could acknowledge the processing status on a batch level. It could be integrated with RESTful or RPC interface. NuMessage is cloud native. The persistent layer is separated with NuMessage itself, and the components in NuMessage could be scaled easily. NuMessage is high performance. It could achieve less than 100 milliseconds with a billion level traffic, especially the non-blocking retry, which we will introduce in details later. NuMessage also designed with extensible in mind, and the underlying persistent layer could be replaced without impacting our end user. Now let's go deep into the design details. The mechanism to manage the status of a batch is one of the biggest contributions in this paper. It helps us to achieve the batch level acknowledgement as well as the retry mechanism. The retry means when a consumer failed to process some messages in one batch, it could mark these messages as retry and specify a delay to this batch. Then, after that specific delay, the NuMessage service will redeliver this message to the consumer side automatically. To be more specific, there are 2 readers in the internal consumer. The normal reader will fetch the message from the source data storage unit in a sequential way. Before delivering this message to the consumer side, it will generate a batch detail to hold the metadata of this batch of messages. And the batch detail storage writer will persist this batch detail information into another storage unit. This batch detail will be loaded into memory finally. When the user sends back the acknowledgement, it will update the batch detail in the memory in the end with this pipeline. Then the retry storage reader could read the batch detail status from this cache and fetch the message that need to be retried from the source data storage unit and return to the consumer side accordingly. Let's see how NuMessage is used in eBay. This is a NuMessage topic use case. The search backend team use HBase to manage the eBay index. Previously, the index update events from the domain producer will persist into HBase through the SDF producer directly, but when the HBase is done, the whole pipeline is blocked. So now they use NuMessage to decouple. The producer will first drop events into NuMessage service, drop the update events into NuMessage service, and the NuMessage SDF consumer will read events from NuMessage service and persist it into the HBase. When the HBase have issues now, the SDF producer and the business domain producer will not be impacted. This is the use case of a NuMessage queue. We leverage queue service to implement a RPC framework. The RPC client produces message into a queue, and the new RPC server will consume from that queue and do the processing logic. If the RPC client needs to receive the response, it will drop the response into a reply queue, and the client side will get the response. This is the monitoring dashboard for the biggest use case in NuMessage today. So the daily traffic of this use case is more than 10 TB. The right side is a sample of a consumer. Note that the 95% end-to-end latency is less than 100 milliseconds, and when the retry happens, the consumed traffic is not impacted, only cause some wave in the latency dashboard. We also did an experiment to compare the NuMessage with Kafka. This test was running with a single thread, and we set the processing time to 20 milliseconds. In theory, each second, the consumer could process 50 messages. But due to the overhead of network, both Kafka and the consumer and the NuMessage could not achieve that. The gap here is showed the overhead. For NuMessage, add one more layer on top of Kafka, so the overhead is bigger than Kafka, but near to it. When we set the client-side field rate to 20%, which do happen in our real production environment sometimes, the performance of Kafka dropped dramatically due to it needed to do the blocking retry on client side. But for NuMessage, the performance is nearly the same with the normal use cases, which prove the value of this paper in one hand. Let's do a briefly summary. In this paper, we introduced a novel messaging solution called NuMessage. The non-blocking retry mechanism is one of its advantage and got approved with experiments. NuMessage is running in production for about 1 year in eBay and handle more than 10 billion messages per day. Thank you.